All right, we're back. We are Game 2005 in the fall 2018 semester at George Brown, and that's game physics. It's week 7, but we're doing lesson 6, part 2, which is all about SDL. We're going to be using the SDL template that I provided on Blackboard to help us do collision detection in Module 3. We're currently sitting at Module 2. Which is the module about physics and Newtonian physics, kinematics, all that kind of stuff. But we need to get familiar with SDL, and that's why I uploaded that template up on Blackboard. So if you haven't had a chance to already, please download it. When you do, when you expand it, you're going to have a folder that probably looks like this. It says SDL template. Inside of there, there's going to be a template folder. That's just the way it was packaged. And if I double click on my template.sln, the solution, then it'll bring up Visual Studio, whatever current version of Visual Studio you have, one day when it responds. My computer's being very funny today. But anyways, it should work for you much better than it's working for me right now. Yay. So what this template is like literally what it says. It's just it's a template that we're going to be modifying, to test collision detection with C++. I'm going to go over the template with you, and I'm going to give you a couple of exercises to get familiar with it. And that's really all. I'm not going to be really handling the physics part that we talked about on Tuesday today. But I'd like to remind you that your lab 4 is due tonight at midnight for your bonus. Okay, so today we're just doing this. There was a class that I had to cancel on Wednesday because of some unforeseen circumstances, but otherwise that's what I'm doing this for, so that you guys can have a chance to see this live, and especially for those people who weren't able to see it on Wednesday. Okay, a couple things. So when you launch the template on the right, let me just change the resolution here so you guys can see it better, because I know I would have trouble seeing that. I'm just going to bring it to 125%, see if that's a little better. Is that better for you guys? Okay. So on the right, you can see we have our solution explorer. Some people like putting it on the left. It's up to you how you do it. I want to point out a couple things. There is, in the header files, we have a game.h file, right? Game.h, again, I'm going to assume for a second that your knowledge of C++ is minimal, all right? Not because I think it is, but because it'll make sure that everyone has the same information, okay? So game.h, we're going to have our, this is where we're going to have our custom game class that we're going to use SDL in. And we have our main CPP, which is going to test everything else. So we really have only 3 files: game.h, game.cpp, and main.cpp. One thing to note is you should be, when you're running this project, in x86 mode. Okay, so please move from, if you're x64, move that to x86, because that's how I've configured this one. Okay, in the future projects, what I'll do is I'll make sure that I have configurations set up for both x64 and x86. Okay. So I'm in debug mode, and if you notice that if I go to my template, one of the problems people have when they run this thing is they get into an error where it says, I'm missing this and I'm missing that. A lot of times there's nothing missing. You need to retarget your solution. So if you right-click on your template on the project, so this is the solution up here, and this is the project that's inside the solution. So the solution is a container that holds many projects, 1 or more projects. In this particular case, there's only 1. I'm going to right-click on my template, and I'm going to go to Properties. Okay, so when I go to Properties, I want to point out that a couple things. One, if you notice, I'm in debug mode. I'm in Win32 for that configuration. You can make as many configurations as you like with Visual Studio for C++. I find that this is one of the things that is a pain in the ass for C++ programming in general, doing this configuration file. But once you get to it, once you've done it a couple times, it becomes a little easier. So under the C++ area, there is general. And I'll notice that there's this big line here in terms of all the stuff that I'm loading. If I was to double or pull down this line and go to edit, I don't want you to change anything, but I want you to notice that with happening. So in the solutions directory, there's an include folder, and it's basically looking in the include folder and then the include GLM folder and in the include SDL includes folder for all of your included libraries. That's where it's looking. Okay, so that's what this is. Okay, I'm just pointing this out so you guys can see what this is. Okay, so that's one change I made. Also, in the linker area, so if I just close this up, I'll collapse this one and go into my linker area. Notice that I've changed the additional library directories to solution directory lib, right? And what that is the lib folder in your directory. Okay, so I'm going to go to that in a second. So these are the things I've changed, just so you know how the configuration has been done. I'm going to right-click here on my template now, and I'm going to go to Open Folder in File Explorer, so you can see where it is. I want to explore this thing. So inside of my, if I go back up one to template, right? You can see that I have a lib folder. So my lib folder has all my lib files, and these are all the things that we need for this project. And I'm going to include other lib files again next week or the week after when you guys get back for other things that you need. I'm going to continue to make everything, actually put together a template that has everything you need to do stuff with minimal effort on your part. I don't want, this is not a C++ course, so it's just, hey, here's the template, use the template. Okay, that's what I want it to be like. I don't want you to sit there and go, so what do I do? How do I do this? How do I put this together? How do I configure it? That's not the exercise. So this is where I'm just showing you where everything is, just in case you want to know these things. So this is the lib folder, and then inside my include folder are all the libraries I've included. Now I've included a couple of interesting libraries. One of them is the IL library, which is a image library for GLM and OpenGL. There's also a GLM library, which is the OpenGL math library. Now we're going to be using this during our third module, right? Because the OpenGL library has interesting classes like vector2, vector3, matrix3, matrix4, a bunch of other different things that we can do, lerping, slurping. We don't have to write those functions. We just have to use those functions, and that's what I want you to do when you do your collision detection. All right, so that's the kind of stuff that I've included. One of the things you may have a problem with when you run this thing, it may not work. The way to fix that is if you go to template and if you right-click, there is a retarget solution, or it says retarget projects, right? See where it says retarget projects? If I go there, it'll bring up a list of SDKs that you have access to. I only have one, but you need to pull up the SDK that's relevant for your system, right? You should only have like one as well, right? If you press OK, what that'll do is it'll retarget your solution so it works on your system, right? Right now, it's made for my system. I have Windows 10, the educational version, and I think I've updated it with Creator Edition, which may not be compatible with what you have. That's why you may have some errors. So again, right-click here on Template, go to Retarget Projects, and when you do that, you can click on the solution that you have. Usually it's already automatically selected, and just press OK. And that should fix most of your problems. When I run this thing, this is what we get. You should have this when you run it. So I run it, and then it'll bring up a little window eventually that basically says hello world. Okay, so that's what you get. So this SDL really, at the end of the day, is a framework, a windowing framework for us, all right, for C++. Think about it as a place where if I wanted to run an OpenGL context or an, a 2D context or whatever I wanted, I could do that here in this in the window. And we're going to be doing a lot of other things in here, but this is where our projects are going to live in the third module that we're going to be working on. Okay, so really what we have here is minimalist stuff. You can see also I have a console window that tells us everything is a success. So if you don't get this, you may have to retarget your solution. Okay. All right, there's this. Okay, next, let's take a look at the stuff that we have. So first, I'm going to go in my game.h file. I'm going to double click here and let's take a look at it. So I'm including IOStream and I've included SDL.h. SDL.h, the way I've been able to include that is because it's part of our includes folder, so I have access to it. And what we're doing here is I'm creating a game class. So this game class, all I'm doing with it is it's encapsulating the SDL stuff, and I'm going to instantiate an object of type game, where I'm going to render my window and my renderer and all those kinds of things. So if you notice, there's two sections to this class. We have a public section right here, and there's also a private section. So what I've got here is a constructor. Here's a constructor and the destructor for this class. Pretty very simple. And I'm forward declaring this inside of this interface, in this game.h interface. That's what it is, right? So I've got my init function, which is basically going to initialize some of my variables. And notice I have an empty one, pretty much, the empty constructor for this function, as well as an init function that takes a title, x and y positions, width and height, and if I want my screen to be full screen or not. That's what that does. Okay. I also have some additional functions that are public: a render function, an update function, a handle events function, a clean function, and also a Boolean that returns if the game is running or not. Okay, that's what these are. These do. We're going to modify these functions over the next several weeks. So every time we come in now into lab, we're going to have a part of the stuff that I'm covering on Tuesdays, right, in lecture. Then I'm also going to come here and we're going to do more stuff with our SDL template. All right, so be prepared to come in. You're going to be working with C++ for the remainder of the semester, even if it's a little thing at a time. We might have one simple exercise that we're doing every single time. But I want you to get familiar with it because, and I'm starting here in week 7, is guess what? I don't want you to come to me in week 11 and say, I don't know what this template does, and I've never seen C++ before, and da-da-da, right? Just saying, right? That's why I'm putting it up now. And so that way you have a lot of practice. I want this to be your code as much as mine, right? So you need to kind of absorb it and look at it so that, it's not confusing. In the private section, we have a couple of, a few pointers here. We have the SDL window pointer, right? That's what this is. So SDL window is the class that is coming from the SDL library. And this pointer, which is m_p window, again, m_p usually denotes private member. That's what it means. That's just a convention. And for the most part, we're good. So these are a pointer, m_p private, so a pointer member. That's what it is usually. And it has a window, a render, and texture. All right, so these are the three things we have. My window and renderer are the two things immediately that I need. And the texture is where I'm going to actually be outputting any kind of images that I have. I don't have anything for today, but next time we get together, I'll have a more comprehensive SDL template for you. I may also get you to pull from GitHub. It might be something I need you to pull from GitHub, but I'm just going through it with you today. I also have a couple of recs. One of them is a SDL rect, which is a source rectangle, and I have another one called the destination rectangle. These are just some basic objects that I've put into the private area of our class. I also have a private m_b, which is a Boolean member, which is running, if the game is running or not. So that's what I've done in my forward declaration. Let's take a look at the game CPP now. So you can see that the constructor and the destructor are both empty. And then we get into this init function. So the init function basically, again, takes the title, x position, y position, height, width, full screen. What we do here is we test if the full screen Boolean has been set. And if true, we set our flags to SDL window full screen. And that's just a flag, an enumeration that comes with the SDL template or library. We then initialize SDL. And the way we do that is if we say if SDL init, so what this does is it calls the SDL init function. And then what we do is we have a number of options here. If you hover over this, you can see that there's tons and tons of options. I can do things like initialize only audio. I can initialize only haptic. SDL actually takes care of all kinds of really cool things. Joysticks, audio, everything in one, which I really like about it. You don't have to do things like, include something like X input or anything like that. If you wanted to do input, it does it all for you, which is pretty cool. So that's SDL. We initialize everything. And if that's true, and if it's greater than or equal to 0, which means there's no error, then I'm going to say something like this. I'm going to output to the console SDL init success. Okay, if this failed somehow, it would skip down to this, which would mean SDL init failure. So somehow if your SDL library couldn't create your context, then it would fail and would come to here, and we would output this, and your window would pretty much close. All right, once we're done with initializing everything for SDL, we go into our create window function, and we're using our m_p window pointer to point to this, the reference to our window itself. This is just a pointer to the window, and the window is that context that comes up. That's what happens. So again, we're passing in our title, x position, y position, height, width, and any flags. And if we set the full screen flag, it's going to go to full screen. That's what that does. Okay. Fine. If the window is not, it doesn't fail, then what we're going to do is we're going to say, hey, window creation success. Let's set up our renderer. So our renderer is going to sit as a container inside of the window context, right? So we have our window. Inside the window, we have think about another rectangle that has, it's all of our, where we're going to render all of our graphics if we have anything like that. So that's our renderer. And what we're going to do here is we're going to create a renderer. And it's going to return a reference to this new renderer to m_p renderer. That's another pointer. It's going to point to the renderer. That's what it's doing here. So that's what this is. If this renderer works, we're going to check this out. And if that's true, we're going to set the draw color for the renderer in the background. And if you see, the draw color right now is white. Okay. With RGB and A, this is our initializer for our renderer. And basically what this does is it draws the color, the background color for the screen. Okay. If it failed, it's going to give you a failure. If the window failed, that's going to give you a failure. And really, that's all that this init function does. It just opens a window, creates a renderer, and sets the color to white. That's what it does. Okay. Then we have a couple more functions, a few more functions. One of them is the render function. So what render does is it clears the screen. That's what it does. And to the draw color. And it does this every frame. Actually, it does it in a loop that you'll see in a second. Okay? And then we're going to redraw. So this clears the screen, and this redraws the screen. It's almost like, think about the render as the stage area, the staging area, or the canvas, if you will. And I'm just redrawing the canvas over and over again every time the renderer is called, render function. I have an update function that right now is empty. We're going to change that later on. We also have a clean function, which basically cleans up our context. So it releases memory back to the system. That's what this does. And then we have a handle events function. And handle events right now, all it cares about is the SDL quit. And SDL quit is the X on your window. So if you click the X on your window, it closes the window. That's what it does. I can put as many other events in here as possible. I can use mouse events. I can listen for keyboard events. I can listen for joystick events. I can listen for all kinds of events in this handle events function. All right. But right now, all we're listening for is quit. Okay, cool. So that is our basic game.cpp and game.h. Let's look at our main.cpp right now. It's a very basic thing. So I've included a couple of libraries here, included the math library and the windows.h library. And as we go forward, I have a couple of things that I've commented out. We can go into and open up later on. But for now, they're commented out for a reason. Just leave them in there for now. I have a couple of additional things. I have glue, which helps us with OpenGL context, as well as GLM, which is our graphics library that I talked about. I have a vector3 here that I've enabled. So if I want to use if I want to make a vector3 class available to my code, I just go glm/vector3. And just to get you an idea of what that is, if you want to look up what GLM is, if I say GLM, I'll look that up. It's the OpenGL mathematics library. This is it. I highly recommend you take a quick look at it. It's got some really, really cool functions in there. Let me just go to the API documentation. And if you go here, there are some core features, right? So what it does is it does a bunch of vector types, matrix types, integer functions, a bunch of different things that it does for you. So if I go to vector types, you can see that there are quite a few vector types that you have. So if I have a integer vector, right, here's an integer vector type. There's a unsigned int vector. There's also a vector 2, 3, and 4, which are floats, floating point numbers. And so that what it is, we need these vectors when it comes to, especially when it comes to collisions. So I say, hey, look, I have this one object here and another object here. Do they collide? I need some transform information. We're going to create a game object class later on. And the game object class is going to have a transform, which we're going to create, very basic stuff. And what's going to happen is when you want to check to see if one object collides with the other, we're going to use different techniques to determine if the objects collide. Okay, so that's what we're doing here with this stuff. All right, so instead of you making all these additional classes, vectors and matrices and all that kind of stuff, they're all made for you. That's why I use this library. I think it's a pretty cool library. It's very popular. Okay, let's go back to this. So I include the GLM library there. I include the game.h file, which is that thing we just included up there. I initialize it. So basically what I've done is here, I created an object of type game, and g_game is equal to 0, basically sets this to null. I kick off my main function. I do a couple things here. I alloc console, and I open up the console window for writing. And this comes from our window.h. All right, so what this allows me to do is show the console. Otherwise, your console won't show at all, right? So I want a console window to give me some feedback, and that's what I do with this. Okay, then what I do is I set up a new game pointer. All right, so I create a new game object. I use the new keyword to allocate memory on the heap, right? And I get a pointer back, and it sits inside of the game g_game variable or pointer variable. Then I immediately go to initializing my window, and I put in hello world, and I pass in the X and Y positions, so 100, 100, and the size of my window, which is 640 by 480, and false. Okay, and then I have this little endless while loop, pretty much, that basically says this: if my game is running, and by default it starts off as true, it is running, right? Then I want to update my handle events, my update function, and my render. I want to call these functions every time this window or this while loop runs. I mean, it's as fast as it can, right? And then afterwards, if my game isn't running anymore, if I press the X button, because handle events will detect that the X button is pressed, it'll change my running status from running to not running, and then it'll exit this while loop, and we can then trigger our clean function to return stuff back to memory. I've got some other stuff I'm going to clean up here, but basically that's what this does. All right, so very, very simple function. So your task, this is task number 1. What I want you to do is I want you to create another init function in your game class. So if you go to your game class, notice that there is one init function. I want you to overload this function with another signature, right? And what I want it to do is give yourself the ability to have any color that I want. I don't want to have just one color. Right now, it only does white window backgrounds. I want you to have, let's say, as an example, any color background that you want. How do I do that? What do you recommend? Anybody have an idea? You guys are like, no, I have no idea what you're talking about, Tom. Right? How about David? David, any ideas? I want to make another init function, instead of opening up a white window, I want to be able to open up any kind of color window I want. What do you recommend? I could use a vector. If I need to use a vector, then I didn't do that in the first time I did this. I need to include GLM vec, whatever it's going to be in here. Now here's the thing. I may want to have RGB and A. I need to maybe have those in there as well, as opposed to X, Y, and Z. So I need a vector 4. So a four-dimensional vector, right? So what I can do to include that is if you look inside your class, I could do something like this. I could say include, and then I want to say GLM. Here's my GLM library. And then if I want to have a vec4, I could do vec4. Okay, so what this does is it includes the vec4 class from my GLM library. Okay, cool. So I can include this. And when I do that, now that vec4 is available to me, right? I want to be able to take in a new vec4, right? That's definitely a way to do that. Okay, so we'll make a couple of initializers. One of them that takes a vec4, another one that just takes RGB and A, let's say. Okay, so how we do that? We would just write another function. I'm just going to copy paste this one for now. So I'm going to copy this function here and paste it. So it's the exact same signature right now. But what I want to do is not just full screen, but at the end of full screen, And maybe what I'll do is I'll leave full screen where it is for now. And I'll just add in, and again, you might want to change the order of this. I'll add in a new vec4 property. So I want a vec4. So I'm going to say glm vec4. I need a vec4. That's the type. And I want to have this thing called color. Right? So I want to color. I'm just going to open this up so you can see it. That's one way of doing it. Okay. Notice that I get this little squiggly line here, and it says that, hey, I've declared another signature for a function, but I don't have a function body. That's what this thing is. Okay. Let's make one more. So I'm going to kind of take one of these. So one of the ones is this one, and let's also include one that doesn't require a vec4, and it will be just taking in the RGBA. Okay. So I want to take a bunch of ints, R, int, G, int, B, int, A. So those are two options. So either I enter my color this way or I enter my color this way. All right, your choice. Okay. I also, if I want to, I can set up defaults for this. Okay, so I can set up defaults for my RGBA. Okay, I could do that. So I could say something like my R is something like 255 by default. My G. Now, here's something. When I do my initializer, do I initialize it here or after the function? What can I do? Would I do it here, or would I do it inside of my my class? Now look what it says here. It says default argument not at end of parameter list. I can keep going, and I can do this here. And I recommend doing it in the H file. I'll be honest with you. I think it's the best place to do it. That's my standing on that. Some people have a different way of doing things. This is my way. You don't have to, but that basically solves it. These are the default values. So if you don't enter anything in, then it's going to be white. All right, that's what's going to happen. So I've got two different signatures. What about if I want to do the same thing here with color? How would I do that? Well, I can just say that it's a new vector3, kind of a new vector object, right? So I could say it's a glm vec4, and I can pass in my colors, which are going to be something like, now this is interesting. I mean, I can pass in whatever I want, but I want to be able to pass in 255, and there can be floats or integers. It depends on what you want. So let's say make them integers. I can do that, right, for my vec4. So this way, what I've done is I've initialized both objects. Just in case you don't enter a color, you're going to get white. Just in case you don't enter in RGBA, you're going to get white. Okay, so those are my default values. Okay, but I still don't have any stuff here that really defines my new functions, right? So what would you do here? David, what would you do next? I want to define my function. What's the quickest way to do that? I could do it right here, but I don't want to do it here in my H. I want to do it in my CPP. So how would I do that? Yeah, you don't have to do your CPP at all. Here's how you do it. So if you look at this little the squiggly line here, and you've got, when you hover over this little light bulb, oh yeah, for sure. Then I'm going to go to Visual Studio, and it's going to say create definition of init in game.cpp. I'm going to click onto it, and what it does, it creates our signature immediately for me. All right, I'm going to save that one, and I'm also going to do it the other one as well. I'm going to do this one. So I'm going to kind of go in here, and I'm going to do a quick actions or refactoring. You can also just hover over the little light bulb there. But either way, we do one way or the other. You can actually initialize your functions immediately in your .cpp file, which is pretty cool. All right, so now that that's done, I'm going to go back to my game.cpp, where I have my two new functions that are initialized. So I've got this one here and this one here. Curious. So what do I do now? I have already some information up here. This is all my stuff. Do I copy all this stuff? Is that what I should do? What do you recommend? Should I copy all this stuff again and then modify stuff? What do you think? Just call it and then modify it. That's what I want to do. I want to call. Why would I modify it? I already have a function. I just call the function within my the other functions, and I'm good to go. So let's do this one first. So I'm going to say that. Oops. I'm going to say that I'm going to call my game init function, and it's going to be the other one. It's going to be the one where I'm going to pass in my title, my X position, my Y position, my width, and my height, as well as my full screen flag. That's all it really needs, right? So this is going to call my previous GLM, my game init function. Let's see why it's giving me an error. It says more than one instance of the overload function matches the argument list, right? Okay, so there's that X position, Y position, height, width, and Boolean. How do I know which one I'm calling is what it's asking. It doesn't understand which one I'm going to call, right? Why? Why is this a problem? Come on, guys. I want you to think about this. Because I've got default values. That's why. Because I went ahead and made default values for my color and all those things, right? Then that means any one of these could fit this functionality. So that was a nice idea that I did in my game.h when I did this, right? But actually it screws me up. So let's go back and erase those things. I'm just putting it out there. If you didn't have to do what I'm doing, if I just copied paste, other than doing what David said, then I could use this. But otherwise, I'm going to have to initialize this in another way. Okay, so I'm going to kind of remove that. But you could do it this way. Definitely, it's a good way of doing things if I was to do this. Actually, let me undo that. Let me undo that change. Sorry, I meant to keep the color value, but not the the default value. Okay, so let's get rid of that. And same thing with all these. So I just have to remove these things. Because what this does is it makes it so that the function signature looks exactly the same to the compiler. And so it doesn't know, it's ambiguous. It doesn't know which one to call, right, when I'm calling that function. And you don't want to, it might think that you're trying to call the function itself. See how that goes away now? All right, so I'm calling the function that only has this, which means these default values, the color, the vec4, if I want a default value, I can do it here too. I can just set the color as default. So I can say that, you know, I call this up. I want to say that the default value is whatever I want. If there's nothing that's been entered, so if my GLM vec4, as an example, has nothing, I can make my own, I can set my own defaults. But for now, what I want to do is I want to change something. I want to change the background color. How do I change the background color? I've got to call this SDL set render draw color function, right? Again. Now, I could check to see if the renderer triggered, but I know if it got by this function somehow that I'm good to go. And how do I know it got by this function? I got to check for it. So I'm going to say something like this. I'm going to say if my game init, as an example, if this is true, if I return positive that I've got my initialization, then I'm going to do an SDL underscore set render draw, right? Color, this one, set render draw color to whatever the color it's going to be. Now, if I get a GLM4 color, which is what I'm getting up here, this is for this function here, I have component parts to the color. I could do something like color dot R, color dot, this is why I love GLM, RGB, color dot B, and then color dot A. Okay, I get those four colors, right? It says, whoa, it says argument of type float is incompatible with parameter SDL renderer. Yeah, I need to have also call the render function in here, which is something I need to do. If you notice that one of the things I need to do is put this m_p renderer. I need to make a reference to that as well. So I'm going to go down here and do one of those. And that should solve my issue. So this is cool. So this is one way I could do it. And if this is true, right, if this is true, then I want to return false. Sorry, I want to return true. Return true, right? So this means that, hey, I initialized. Right? Because I always want to be able to return that I've initialized or not, right? Well, otherwise, I return false. I could put an else statement here, but the only way this is going to come to line 71 is if this fails. So I don't really have to put an else statement in here. This is one thing I could do. So this is one change I can make for my overload. And then I could do the same thing for this one, which is slightly different. I could say, oops, I could say, kind of similar to what I've done. I'm just going to copy and paste this part here for a second. Now, I don't have a color this time. I don't have color.rgba. I just have RGBA. So I just have to take those out. R, B, B. Okay. And that would take care of that function. All right, so those are the two overload functions we just created, just to be able to handle screen color changes, okay? We have to test this now and see if it works. Are we good so far? Anyone not good? Okay, guys, like you need to understand, yes, you're not good? What's not good? You don't understand? Okay, well, we'll do this quickly, and then we'll take a short break, and then I'll come over to you and I'll work with you, okay? All right, so I've got my two init functions, and they're going to trigger. I'm going to go to my main.cpp now, and we have this initialization, right? Okay, cool. How do I call, or when do I call my init function? It really doesn't matter. As long as I call it at some point after I create my window, I'm good to go, okay? So I can go here. Now, this init function, notice it takes the hello world. What about if I just said something like this? I said that I want let's try this. I want to try 255, 255, 0, 255. That's going to give me or should give me a yellow window, right? Does that make sense? I'm going to get a yellow window here. All right, so let's try this out. I'm going to run it, and if everything goes well, then I should pop up with a yellow window if I did it right. Yay, right? So that my function worked, yes. Oh, you're happy. Okay, good. That's one way of doing it. The other way is I could declare, now I didn't have a GLM vec4 here. I could just make this GLM vec4 instead of vec3, right? Because we can just use that. So I include that library here. I just make that change. And what I could do is I could create a color. So I could make it something like GLM vec4. Let's call it base color, right? There it is. And I could set my base color to a value. So I can say a GLM vec4, and I can set my base color to something else. Like, for example, let's say I want to make it gray. So I want to say 128, 128, 128, and 255. I could do that, right? Once I've got this, I can just pass in my base color in here instead with my overload. I can just say, you know what, don't pass these values, just pass in base color. And that would work because we're listening for a vec4 inside of my class, which is it's a much cleaner thing to me, this way of doing it, right? Instead of passing in individual integers, right? So that's one thing you could do. And let's try this out. If my base color is 128, 128, 120, if everything works, we should test this out. I should get a gray window, okay? So let's see if that works. So I'm going to run it. And I should come up with a gray window now, right? Pretty cool. So that's a very simple way of doing stuff. There's nothing fantastic or beautiful here. But one thing I wanted to show you is just a couple of ways we can make the context go. So this is where the window's going to be. SDL has a ton of different functions that we can tap into. So here's your challenge for today. I'm going to stop recording this in a few minutes, but here's the challenge for you guys. And I want you guys to help me. How do I make it so every 10 frames, right, my window color changes to a random color? Right? So now this is something different I'm asking for, right? Anybody have an idea what to do? Think about what we can do here. We can call m_p, sorry, we can call the init function. That's cool. Do I have access to the renderer though? Well, let's take a look. Do I really? If I go to my game.h, okay, I have the render function, which just cleans up my render, like just redraws my screen. But what about this stuff? All this stuff, private, it's all inside here. And I need my renderer in order for me to change my color, right? So I could make this public, but I recommend against it. From an object-oriented programming perspective, you want to use information hiding, the idea that you're going to hide information away and only give access to the user, to the information that they need. So I really need some kind of accessor, some kind of method that gives me access to this thing that returns a reference to my renderer, or something that allows me to set the color outside of my init function. Okay, that's what I recommend. So example is if I said something like set, render color or something like that, right? also, when you name your functions, I want you to be a little sensitive in terms of what function already exists. I couldn't call SDL set render draw color because I need a reference to the renderer. So I could return a reference to the renderer by get renderer. I could do that, and then call the SDL function. That's one way of doing it. If I don't want an access to the renderer, like let's say for some reason I don't want you guys to have access to the renderer, then I could make a set or a getter, right? That just gives me the ability for me to set my render draw color, right, from my game. Okay, so that's one thing I could do. What do you recommend? Do I want access to the renderer, or do I want to create a setter for the color? What do you think is just better? I recommend the setter for the color for now. We can always get a reference to the renderer later. For now, I think setter to the color is fine. Everyone will do this differently. Some people will prefer the other way. Okay, I need to make this public, so I'm going to make a brand new function. I'm just going to put it down here, and I'm basically going to it's going to return void, right? And I'm going to call this set. And again, I'm just going to call it almost the exact same thing here, set render draw color, right? So set render draw color, right? And I want to set up a draw color, which is going to be, again, if I do this, I could take in a vec4, I could take in RGBA. So I need two signatures for this function, right? Again, so I could say I need a GLM vec4, which is going to be called color. I'm using the American color, by the way. Please forgive me, only because it's used everywhere, and that way I'm keeping consistent, not because I think it's right. And then I want to make another one, set render draw color, where I pass in RGBA values, RGBA, right? So I pass in those things. So I've got two little functions here. Neither of them have been defined. Again, I'm just going to use the quick definer here with this little light bulb. I'm going to create the definition for this one. And I'm going to do the same thing with the other one. I'm just going to hover over, go to the light bulb, and create my definition, right, really quickly. And once I've done that, if I go to my game.cpp now, I can define those two new functions, right? So here's the two new functions, right? Notice I take a GLM vec4 and RGBA. What do I really want to do? I just want to call this right here, right? And I got to be really careful. I mean, I'm going to assume here, this is the challenge, all right? I'm going to assume that the renderer has been initialized, right? So the way to think about this is if I go to my renderer, I can check that this is not 0, right? And that's the only time that I'll initialize my color, right? So I recommend doing something like this. I really do, right? And I'm going to take this whole thing, actually, this whole piece here, because this is something that I want to be able to do. Now, if you think about this, if you're really careful and you think about this carefully here, I could create a method that even this function uses, right? These little set methods or whatever, I could call them within my function so that I don't duplicate my code, right? But we're going to get to that in a second. So I'm going to copy this. I'm going to go back down inside these little functions in here. So here's my draw color. I'm going to put this in here. And I want to check to see this because, you know, and again, I'm returning void, right, as an example. I don't care about returning void right now. All I care about is giving a message that, hey, guess what? You know, render init failure, right? And I want to check this because I don't want to try and set the render draw color, because if I do this, it's going to crash my window. That's what I'll try and do. If somehow the renderer, for whatever reason, isn't initialized, right, it'll crash everything. I don't want that to happen. So I want to set up this little, you know, kind of, it's almost like a try catch. I could do a try catch as well, where I kind of throw an error saying, error, you know, there's a problem with your renderer. I could do that. But that was, again, I would stop my operation. I don't want that to happen. So, so here I'm saying render creation success, right? I'll say, instead of this, I won't do this. So we probably already have that, right? I don't have to, or I could say something like, let me go back. You know, renderer active, or render, you know, active, something like that, because we know that it needs to be active for us to set the color, right? Now remember, if I'm going to set the draw color every frame, every 10 frames, I mean, I'm going to see this render active over and over again, right? I could also say, I could print out my color that I'm drawing too. But for now, because I don't want a lot of stuff up to the console, I'm just going to remove this whole thing. And in fact, what I'll do is I'll just comment it out because you make use of it later on. Okay. This one I definitely want though. Render init fail. That's like an error for my code. Now in here, I don't want these values. I want the values that I get from my color, right? So I could say again, color.r, color.g, color.b, and then color.a. So I could do that. That takes care of my draw color with a vec4, which is a color, right? That I'm getting a vec4 variable. Now let's copy this part here, and I'll go and make the overloaded version, which does the same thing, but instead of taking our color, I'm just going to go RGB. But depending on what the user decides to put in, we have an overloaded function that does one or the other. Yes, that kind of does either one or the other. What do you think? Do you think this covers it? I could also take in floats. I could take in U bytes. I can take in a bunch of different kinds of things that I want to make this more accessible to the user as I'm building out my game class. Okay, so set render draw color, set draw color, set render draw color, different kinds. Okay, cool. If you think about it, I could call set render draw color. I could call this from here, set render draw color, because I'm kind of doing the same thing here, right? I mean, I can replace this code by calling that. Okay, I could do that. Right? I'm just putting it out there to you, right? And that's not a bad solution, but if I was to do this, now I could do that even here because I forward declared my stuff in the .h file. So I could call my function, the GLM the function below, in here. The only thing is that I probably would want to change my message somehow. So maybe I have different messages, a message flag that I could turn on or off depending on what I'm doing. For now, though, I'm going to leave it like this. I don't want to confuse you guys anymore than what I'm doing. That's a refactoring step. Okay, so there it is. This is my stuff. These are the two functions. Yay. I'm going to save this. I'm going to go back to main now. So I've got my two functions. That means now inside this while loop is where I want to do these changes here, right? I could also do it in the update loop inside my game, one of the two, right? Random colors. But for now, let's try and do it here outside in the while loop, right? So what I want to do is, okay, after I handle events and update and render, I want to change my color by calling the game set draw color function, right, to some random color, let's say between 0 and 255. So how would I do that? Well, I've already included my math.h, which gives me the rand function, right? So I could come in here and do something like this. I could say g_game. Because game, I've declared it with memory with a new keyword, I can use the arrow function, and I could say something like set render draw color. Notice that these are all the options that are made available to me from a public perspective. So I could say set render draw color now. And I have two overloaded functions. One of them could be the GLM4 color, and the other one is my RGBA, depending on which one I want to use. All right, let's use the first one, right? And I'll make it an anonymous color. So I'm not going to make a custom variable. I'll say GLM vec4. I'm going to pass in a value for this, right? And I want to pass in rand values. So I want to use rand, right, times 256, and then rand times 256, and then rand times 256, and then 255 for my alpha value. So the fourth value is always an alpha value, right? And what this does is it would call my set draw color function. I'm using the vec4 version. That's the signature I'm using. I could also put in single values for RGB and A, but I figured this is a little bit cleaner, right? And what it's going to do is, if it works, right? I don't know if it's going to work yet. It's going to call the set draw color function that I just created every single time my my while loop goes. That's really much faster than every 10 frames. So let's do it this way. Let's see how fast the color will change. And I do apologize. It'll be a bit of a light show in the beginning. Okay, it's going to go really, really fast. I want it to be a lot slower than this, and we need to figure out how to do that with SDL. Okay, so run it. What's that? All right. So what the heck? What did I do? I forgot a semicolon. Right. What else? That was it. Okay, let's try that again. And black. What the heck? Why did I get black? That was weird, right? Over here, it looks like I've got all my successes, but now when I come over here, I'm not cool. All right. Well, let's, instead of doing some random colors, let's just comment this out. So I'm going to kind of copy this thing, right? And I want to see what we're doing. Let's copy paste, and let's comment this out, and just do one color. Let's make it so it's not a random color. Let's make it so that it is whatever color I want. Let's make it so that instead of it being black, I want to make it so that it is a red color. So we'll say that it's 255, and we'll make it 0 and 0. Let's see if this works. If the screen goes red. Like, these are important steps, right? Because we want to make sure this goes. Okay, let's run this thing and see if that works. So it's not random, it's a set color. Red. Okay, cool. So what happened? Red worked. What happened to my rand? How come rand gave me that weird effect? Could. I don't need to. To test this out, if I want a random number, let's just put it. Let's just do some further tests. Let's do an std, cout. We'll pass in a rand color that's something like 255, and let's see what happens. Every part of the while loop. Let's see what I get when I get this value. When I do this, so I want to do this every single time. Let's say to 256. To make sure it goes from 0 to 255, okay? So that's what this does. And let's see what we're getting here, right? Okay, and run. I know this is exciting, but let's see what the colors I get. Whoa, that's messed up. Why am I getting such a large number? Oh, yeah. We've got to, not times. I want to do this. Okay. Let's try this out again. That would be weird, right? That's more like it, right? And that was the error. So we're getting this massive color, what doesn't know what to do with, didn't crash SDL somehow, but we got the wrong values in there, and that's what the problem was. So we know what the problem is now. Let's go back to this, and we'll change this to a %. That's what I meant to do. All right, and that should work now. Let's see if that works, right? So now we're getting way too fast though, right? It's gonna be like a light show, like I said, right? Yeah, it's a bit of a light show. So how do I make this so that it's not random like this, but actually it's random every 10 frames? 10 frames is what this exercise is all about. It's not the randomness. I'm not trying to give you a light show. I'm trying to give you some, I want to try to get you to understand how to slow things down with SDL. So what do I do here? Any idea? Well, we want to mark frames. So I could create like a delta time. I could do all that work. And by the way, I tried doing that with the class on Tuesday. Waste of time. SDL has some built-in functions that I could use. Now, I'm not saying it's clean or anything, but this is what you could do. You could say SDL underscore, and I want to almost like put a delay, right, with a number of milliseconds. Okay, so every 10 frames. If we assume that we're running at 60 frames per second, if we assume that, okay? We don't know how fast we're running right now. We don't know the default speed that SDL is set to, but if we assume every 10 frames, it's 60 frames per second, let's just say, then we can assume that if it's 60 frames, that each frame is approximately 16.6666 milliseconds, because it's 60 frames over, 60 frames in a second, right? And each second is 1,000 milliseconds, right? So if you take 1,000 divided by 60, you get something like 16.66666 non-terminated repeating, right? So I could put something in like, okay, so if it's 10 frames, it's like 166, whatever it's going to be, right? So 166, millisecond delay. That's 10 frames, and then I want to do that. Okay, so let's see if that actually works. Okay, so I want to delay for 166 frames. Don't do this until that happens. Is this great? No, but it works. Let me show you how that works out. If I was to do that now, we can see that it's every 10 frames, so a lot slower than before. And if you want to make this approximately every second, then you would just put in 1,000 in here. So say, well, every second, I want to kind of click down, and I want to have, kind of this working approximately every second, right? So every second it's going to change color. It's not bad. I don't think it's exactly running at the right rate, but it's not bad. Okay, so that's 1,000 millisecond delay, right? So change the color of the background every second. So why did I bother doing this little exercise with you? Like, it's not really that exciting, right? But the reason why is because we're going to be doing some stuff in here in the while loop a lot of times, right? We may also change the updates inside the game in future iterations of this code that we come together. So this is your first tutorial with this. We get together again. We're going to use it again, this template. And whether we run it in the update loop that's inside the game class, or we run it here inside of our while loop, it doesn't really matter at the end of the day for now. But later on, we're going to do some animation. We're going to move things around on the screen with some images. In order for us to do that, we need some kind of game loop. This is it. We can use this. And we can use a delay to kind of come up with, to delay a certain function that we're going to be calling that does all this work, okay, for us. That's one way of doing it. That's all I really want you to do for today. I think we've run about an hour, and I now want to kind of go around and see if you guys have any questions. I know one student here has an issue with his not working. I want to kind of sit with you and make sure it works for you. And I want to answer. So any questions around this template? So guys, this is the template that we're going to be using going forward. Before I sign off, though, please remember your lab 4 is due tonight at midnight. It's worth bonus marks. I know that there's some people that are not doing the labs because of the bonus mark thing, and it's usually the people who need the bonus marks don't do the lab. It's the people who don't need them that do the lab, and they end up getting like 100% in the course, but they don't really need to do the labs, but they like doing math, or they like doing physics. But I recommend that you do the labs. Yes. Can you hand it in tomorrow? Okay. Test today? Sure. You can handle it tomorrow. I will give you a chance to, I'll accept it. No problem. As long as it gets in there before next week. Yeah. All that stuff should be done. When you come back from reading week, you should have everything, all your marks up to date, right? Because I want to make sure that you guys, the first half is all taken care of, okay? Any other questions? All right, that's it. I'm going to sign off. And I will see you guys, for the people that don't need my help, in a couple weeks, right? On Tuesday.